For VLAN Trunking Protocol, or VTP, this is used for administrating VLANs, adding or removing VLANs basically, on a layer 2 network. When you implement VTP, you need to specify a couple of things. You need to specify the mode, the domain, and there are other additional parameters depending on what is needed. For each of the LAN components, we need to determine the best VTP mode that should be configured. The three modes are server, client, and transparent mode. From a deployment perspective, you have two options for how these modes are used. Number one, you can use VTP server and client mode among the switches, or all your switches are enabled for VTP transparent mode, which is the second deployment option. So let's discuss these two particular options further. If your LAN topology will use VTP server and VTP client mode, then one or two switches in that topology will be enabled as VTP servers. This is typically enabled on the core or distribution switches. So in VTP server mode, on this switch, you can manage all of the VLANs that are used. This means adding or removing VLANs that are necessary. Then those managed VLANs will be propagated to other layer 2 switches in the same VTP domain. So these VTP changes can update other layer 2 devices that can operate in either VTP client mode or server mode. Therefore, for VTP client mode, it is read-only and cannot create or remove VLANs locally. They can only receive VLAN information that has been created from a VTP server in the same domain. So a VTP client mode is typically deployed on access layer switches in the topology. But there is a significant danger when using VTP server and client mode, and that involves the configuration revision value. So let's use this sample network to illustrate this possible danger. So we have two switches on our network. The switch on the left is in VTP server mode, and the switch on the right is in VTP client mode. Therefore, all VLANs created or deleted must occur on the VTP server switch, like adding VLAN 2, which could be used for one of our client networks in this topology. When the VTP server switch makes any changes to the VLAN database, it will increase the configuration revision number. So let's say that it increases it to the revision number of 100. Well, the VLAN changes will be propagated through the VTP domain, and our VTP client switch will receive this update, and it will see that the revision number is 100. Now, if the configuration revision number in that update is higher than what that VTP client already has, it will accept those VLAN changes made by the VTP server. So in this case, VLAN 2 will be added to the switch on the right. However, let's say that we have some rogue switch that is part of the same VTP domain. Maybe it's used in a lab for testing or something like that. Well, that switch is also operating in VTP server mode. Now, this switch is not plugged into our network, but it has a different set of VLANs. Let's say that it only has VLAN 1 in its database, and that the current revision number on that switch is 110. When that rogue switch is plugged into our network, it will advertise its list of VLANs, which will be VLAN 1, along with the revision number on that update, which again is 110, which is higher than what the other switches have, which is 100. As a result, those two switches will see that the update has a higher revision number, and it will accept the VLAN information, and it will remove VLAN 2 from the production environment. In that case, that client network will be down across our entire environment. So this is the danger of VTP if you are using a VTP server and client mode deployment. Therefore, in summary, a switch that is enabled as a VTP server or client mode will only accept changes from a switch that advertise VLAN information with a higher configuration revision number. Now, if the revision number is smaller than what that switch has, then the switches will simply ignore those details and it will flood it out to other switches. So using VTP server and client mode, as you can tell, this is very ideal for large environments when administrating a large number of VLANs, but the dangers should strongly be considered. The other option for deploying VTP is enabling all your switches in transparent mode. In this mode, it is not impacted by the dangers of rogue switches being plugged into the network with a higher configuration revision number. But all VLANs must be managed one by one on each switch in the topology. So for example, if you are adding a new guest VLAN, then that must be manually added to all your switches unless you are using scripting tools like cat tools, for example, by Kiwi. But again, it avoids losing an entire VLAN or VLANs on the network that can occur if you are using VTP server in client mode. Between these three modes or two deployment options, VTP transparent mode is the recommended mode that should be deployed on all switches because of the dangers that I covered earlier. A danger like that can be a security concern because the entire network can easily become inaccessible. Another VTP configuration detail is defining the VTP domain and using VTP passwords, which is optional. So a VTP domain, this must be defined for each switch regardless on the VTP mode that is configured. This becomes very important when using VTP server and client modes on the layer 2 network. But a VTP domain, it defines a group of common switches that you want to manage VLANs for, such as a user network or a guest network perhaps. VTP passwords is applicable if you're using VTP server and client mode deployments. So if you're using those modes, then you can configure a VTP password that each switch in that domain must have for creating or accepting VLAN changes. That can help to avoid the dangers of VTP. However, if that rogue switch is configured with the same password, then those dangers will still exist. In our environment, based on our design, we will be doing the following based on data center best practices and the concepts that we covered. So for one, all of our data center switches, the VTP domain name will be called RHG, our company name, Route Hub Group. And we will enable VTP transparent mode on all of our switches. This means that all VLANs must be managed, created, or removed on each switch in our environment. But that is okay because again, it avoids the risk of the configuration revision issue or any security risk that could happen. I'll discuss this further when we cover the spanning tree protocol. So these are the details for how we will configure VTP, which we will do in the next video. Let's now begin configuring our data center network starting with VTP. We'll start on the primary data center core switch, which we're connected to. Let's first get into the configuration mode. Okay, and in order to enable VTP services on the switch, we need to activate that feature. Next, we need to set the VTP domain for our data center switches, and we will call that RHG, our company name. Next, we need to define the VTP mode, and that will be the transparent mode. Great, and that is all that we need to set up. We need to repeat the same configuration on our other data center switches. Therefore, let's go to the secondary core switch by going to this tab of DC2, and let's configure VTP the same way. We'll first activate that feature. We will set the VTP domain and the VTP mode to be transparent. Great. Now let's go to the data center access switch number 1, DCA1. Let's go to that tab and let's configure VTP the same way. Let's activate the feature. Let's set the VTP domain for RHG and set the VTP mode for transparent. And finally, let's go to DCA2, our second access switch, and configure VTP there. And we'll set the domain and then the mode. With that completed, let's go back to DC1, our primary data center core. And to view the details of how VTP is configured on a switch, you will type in the following command, and that will be show VTP status. And this is similar to the command used with Cisco IOS. Here on our primary core switch, we see the VTP mode that we set up, which is transparent mode. And we also see the domain name that we set up, which is RHG. You'll also see that the configuration revision number is 0 because of the VTP mode that we are using. So basically, the use of the configuration revision is disabled and won't impact our data center switches. We can use the same command on our other switches like DCA1. So there, let's do a show VTP status. And there we will see the same details such as the VTP mode and the VTP domain that we set up earlier. And that will conclude what is needed for VTP, the VLAN trunking protocol.